Hey, this is Rob Sparry.
Hey, this is Brennan Hillary.
In this video, we're going to show you how to implement a dual battery configuration for the Honda Pioneer 1000. We'll include an isolator, a dual voltmeter with relay, a stinger relay, some bus bars, a key-on harness assembly, and a fuse box. Now, we've seen a number of good videos out there on dual batteries, but they left us with a few questions and a little bit of confusion, so we decided to make our own video so that we would understand it better. Hope this works for you. Ready to do it?
Let's do it.
Let's talk about wiring, something we should do during the planning phase before we start wiring. Here we have our main battery. Here we have the auxiliary battery. The job of the main battery, which came with the vehicle, is to start the vehicle and also provide electronics power for things like the transmission, the clutch in particular, and circuits like the headlights and the brake lights, for example. The auxiliary battery we're adding, that is primarily to keep the accessories that we're going to add from drawing on the main battery. We have a negative bus bar. The negative bus bar is good for all negative connections. It's tied to frame ground. The positive bus bar is something that I'm adding for convenience. It's not really necessary, but I wanted to put that in order to be able to add new accessories without having to tap into or overlay cables on top of the battery terminals or other posts. The positive bus bar is only for accessories. It's not part of the main electronic circuit. All right, so the positive bus bar is tied into the isolator. The isolator is from a kit I got at Honda Side-by-Side Club. And the positive terminal from the main battery is also tied into the isolator. There's two main posts. There's a little negative wire that comes out of the isolator. Of course, that's tied back to our negative bus. So the main positive connection is also tapped into our dual voltmeter. This dual voltmeter also came with the isolator kit, as did the voltmeter relay, which we'll talk about in a moment. So the positive lead for the main battery we're going to use to monitor the health of the main battery. The positive lead from the auxiliary battery is going to be tied into the lower voltmeter. We're going to use that to monitor the health of the auxiliary battery. This dual voltmeter is going to be mounted into the switch plate up in the dashboard. The negative lead from the dual voltmeter is going to be tied to the voltmeter relay. And of course that is tied back to the negative bus. This little jumper here, this negative jumper, was already pre-wired. I did not have to add that. The positive lead of the voltmeter relay is going to be tied back to our fuse box. Now, the fuse box, I did not add a switch-in line for the voltmeter. I did not feel it was necessary to have to flip a switch in order for the voltmeter to come on. So as soon as we get power from the accessory circuit, the voltmeter will just come on. So how do we get power to the fuse box? Well, there are a couple of different ways to tap into what we call key-on power. That means when the accessory is turned on from the key. There's a key-on harness. We have one of these on order from the Honda Side-by-Side Club. It taps into the cigarette lighter adapter that's at the base of the console under the dash. There's a harness you pull out, plug this guy in, and then plug the harness back on, and you've tapped into the accessory power without having to splice wires. Other ways that can be done, accessory circuit is the fifth fuse down in the main fuse box. There are little taps you can buy. Some people literally splice into the wire under the fuse box. There's a couple different ways to get to it. I haven't decided exactly what I'm doing yet as far as getting key-on power. We'll figure that out when we get there. Anyway, once we turn the key accessory on, the stinger relay, the low current side of the stinger relay, will be energized, and that will in turn trigger the higher current side of the relay. The positive is tied to the positive bus, and the other side is tied to the fuse box. So the relay will basically turn the fuse box on when we turn the key on to the accessory position. Now, we talked about position number 1 already I've used for the voltmeter. Position number 2, as an example here, I've got a 5 amp fuse in here, and it's shown going back to a switch in the switch panel. When the switch is closed, it will allow current to flow through the switch and go to the positive side of my accessory. The negative side of the accessory, of course, is tied to the negative bus. Now, I actually have a USB power adapter, power port in my switch plate, and I do not have a switch on that. So I did not use a switch for the USB port. It's just on as soon as the accessory is turned on. But this is 16 gauge wire, and it's not very high current draw. The distance is pretty short. There's only about 2, maybe 3 feet at the most between the fuse box and the dashboard. If you get to a higher current and longer distance circuit, like say, so 15 amps, and let's say you're going to have a light bar or rear tail lights or something like that, you might want to consider using higher gauge wire, let's say 12 gauge, but keep in mind that current is going to be going through to the switch up at your fingertips before it gets to the accessory. In that case, you might want to consider using a relay, not unlike the voltmeter here. So you've got a low power, low current at your fingertips when you hit the switch, and you can use the 16 gauge wire. And then the accessory is actually tied to the higher current side of the relay where it can have a higher current draw and a lower gauge wire. I believe that is it. So let's get wiring. Okay, here's our supply table. It's always good to check everything out in the planning phase of your project so that you don't forget something. It's horrible to have to run to the hardware store or wait for an Amazon delivery while you're in the middle of your project. So let's identify everything. We've got our auxiliary battery. I have a Mighty Max. It's about 54 bucks. I know some guys get the Odyssey Extreme. That's about $185. I didn't want to spend that much money. Here we've got the Tru Isolator kit. I believe I got this from a Honda side-by-side store. I did not know it at the time. It comes with a dual voltage meter, and I went and bought a voltage meter separately because I didn't realize it came with one. So that's my bad, and I have an extra one now. I bought some extra battery leads. Some guys said they came in handy. I don't know if I'm going to need them or not. They weren't that much, but I think it was about 10, 12 bucks. Here we've got our Stinger relay. Here we've got our key-on power harness. I also got this from the Honda Side-by-Side Club. This is convenient to tap into the cigarette lighter harness so that you don't have to do any wire splicing. It's very convenient in order to tap into the accessory circuit. I know a lot of guys, they go to the main fuse box here and come down to the 5th circuit down, which is the accessories, but you got to get under here and you got to find the right black and white wire, and you got to tap into it. Some people use a tap. There's like a little tap system you can get, but I decided to be lazy and I'm just using this. It's going to be a lot easier. Here I have my fuse box. I like this type of style because it's got little bulbs that show when a circuit has been blown. If a fuse is blown, a red light will show up, so that's kind of cool. A switch plate here from PBR Products, great folks. These are the little wires that came with the switch plate. It also comes with rivets for mounting. I believe I'm not going to use the rivets. I think I'm going to use screws because in order to get behind the switch plate after it's all been installed, if you need to do any troubleshooting or add new switches, I think you have to get behind the plate and press in these little flyouts and push them out from behind. And I think that would be pretty difficult if it's riveted in. So I'm going to plan on using some old screws I got lying around instead. This is some 3/8" flex tubing that I had from an old project. I used it for making an extension I made for my battery tender. I'll tell you about that. The battery tender is just a little trickle charger that I'm going to use. I want to have the connector hooked up pretty much all the time so that it's easy to plug right into that battery tender when I pull it in the garage at night. And so the lead on it wasn't quite long enough, and I needed to splice in some extra length. I had some old 12 gauge wire here from an old project, and I used my new little Crimp connector kit and some butt connectors, which you just squeeze, and it's okay. The gauge of this is 12 gauge, and the gauge of the battery tender is only 14 gauge. But as long as you get a good crimp, that's okay. And so the flex tubing is nice because otherwise these two wires are kind of separated and they can get snagged easily on things as they route through the electrical compartment, and I didn't want that. I want a little bit nicer look. Here we've got our heat gun for doing shrink tubing, and some guys use I think it's a grill lighter or other things like that. That's perfectly fine. I decided I wanted to use like a little $11 heat gun and just have a little bit less intense heat and no flame. Here's a Klein Tools wire stripper. It's awesome. I highly recommend it. This can go anywhere from 22 gauge down to 8 gauge. And it does a perfect job of holding the cable and stripping exactly what you need to do a nice clean crimp. So you don't have to be a surgeon perfectionist with your dikes. Of course, we've got regular tools everybody's going to have around. You should have a voltmeter for testing. You're probably going to need a drill. Let's see, have I done everything? I think I missed the bus bars. So I've got a couple of bus bars here. I'm only planning to use one bus bar. It's going to be for the negative. If I decide to do a positive bus bar, at least I've got it. These were pretty inexpensive. Of course, you got some zip ties. And I believe that is everything. So let's get to it. Well, in spite of all the planning, there were a few additional items I had to go out to the hardware store to pick up. I'm going to tell you about those. One is this red electrical tape. Now, that was really only needed for cosmetic reasons. I had plenty of black tape, but I wanted to use red on the positive cables where appropriate. Same thing for the red heat shrink tubing. I did not have to go get red heat shrink, but I wanted to use that on the red cables. Some of the loop connectors that came in the kit I bought did not have large enough holes to get over the battery posts or the isolator posts, so I had to buy a couple extra of these. Also, some of the spade lugs, spade connectors that came in the kit would not handle my 12 gauge wire. Now, I know some folks use 16 gauge wire on pretty much all of their switch connections, but there are some that I really wanted to use 12 gauge wire on. Okay, lastly, this green board here is called Green Guard Project Panel. It's like a foam insulation. I'm going to show you a little bit later where I use that. I cut out a little piece. It was only $5 from the Lowe's, and used that for the fuse box mounting. All right, hopefully that's about it. One more thing I want to tell you about supplies that I had to fix in the middle of the project was the battery post bolts. They are too short in the original battery. When I went to add the additional cables for the stinger, etc., I did not have enough thread left to get through everything. So I had to buy a pair of metric size 6 by 20 millimeters. The pitch is 1, that's a standard pitch. So M6 by 20 with a pitch of 1. And one of the things we want to do is make a convenient connection for our trickle charging. The battery tender here is available at Walmart, Amazon, places like that. Any auto parts store probably has one of these. You want to make sure you get one that's got a monitor mode so that it doesn't overcharge, that it goes into just maintenance when it's fully charged. It has a connection for a quick disconnect, which of course will go on to the battery side. And the plan is to take the battery lead, hook it to the positive terminal, of course, and the negative. There's an inline fuse for protection. We're going to route the cable. I haven't decided exactly where yet, but we're going to route it through, stay away from the radiator, anything hot that might cause damage to the cable. The plan is right now to bring it out through the front grill, zip tie it here, and this weatherproof cap should keep it safe for when we are in inclement weather and whatnot, but makes it super easy to connect when we're ready for charging. Okay, so here we have our battery tender wiring. This is the trickle charger. You can see that there is a positive going to the main battery and the negative from the main battery. They are going through the 3/8 inch flex tube, goes down here by this coolant reservoir. It's routed through and zip tied to a couple of metal bars down there. They're kept away from the radiator carefully, so no damage can be done from the heat from the radiator. You'll have to take my word for it, but they're routed around under the wheel well and tied nicely to some metal bars. And it's out here through the grill. I've zip tied it right here so that it won't flap around too much, and it can just kind of hang here with its weatherproof cap. And then when we're ready to do any kind of trickle charging, it's very easy to hook right up. I usually find that it's easier to work in the wiring area and your second battery if you pop off this air filter cover. Now there is one connector in the back that really shouldn't be taken out unless you really feel like wrestling with it. So I'm just going to pop this first little pressure spot here to pop it up and kind of peel it back a little bit. Now there is a retaining ring here, and we'll put that back when we're ready to plug her back together. So anyway, just moving this thing aside a little bit gives us a lot more room to work in the compartment. Nice thing that they did from the factory was provide a secondary negative wire that we can use to go to our auxiliary battery. It's taped up here, and there's a little zip tie. We're going to cut that. We're going to cut this tape. We're going to route it around to the auxiliary battery. So the factory negative extra cable has been snipped away from the tape and the zip tie. We've peeled it back a little bit and run it to the negative of our secondary battery. There's an additional negative lead that we're going to use to connect to our negative bus bar. The positive lead on the auxiliary battery here is going to go to the isolator, and there's an additional lead, a positive lead that I've got that we're going to send to the positive bus bar. That way, once the battery is installed into its little compartment, I won't have to connect or reconnect or screw these things down again. And by the way, I've put tape on these leads to make sure that if they touch anything, I won't get any sparks, because at this point I've had to get things connected, because once I put them in there, it's going to be hard to get to. All right. All right, next we're going to get the isolator installed. This is from the kit. It comes with pretty much everything you need. It does not have screws, but it doesn't look like most people use the screws anyway. They just use the Velcro. It comes with an alcohol pad to clean, and we're going to do that first. And then we're going to mount it in here. We're going to run positive from each of the batteries, the primary battery and the secondary battery. It doesn't matter which you use. You can't install it backwards. And then there's a negative that we're going to run to our negative bus. All right. All right, we've got our spot cleaned out. We've got our Velcro on both sides, and we're going to slip this guy in, hopefully once, and that is it. Give it a nice little press. We're going to add both positive and negative bus bars, a decision that was made sort of on the fly, because getting to these battery terminals is a little difficult, and I don't want to have to get to them repeatedly. In fact, I ended up reorienting the battery position. Originally, the terminals were up here, and they're very difficult to get to when they were back here. And here I have, in this orientation, I have a lot more ability to angle the cables and not have them cramped. It does take away from my ability. I was going to mount the fuse box back here, but now I'm going to rethink that. So we have two positive connections. One is using one of the additional battery cables that I purchased, and that is coming up to the isolator. It's not yet connected. I'll do that later. The other connection going to the positive is going to go to our positive bus bar, which we're going to mount over here. All right, this bus bar has a cover, but we're probably also going to put tape around it to make sure that the positive terminals are not exposed. And then we'll probably put the negative bus bar on the other side. We'll get to that a little bit later. Here we have the negative bus bar. Ultimately, it was a little bit of a challenge to get it mounted, but worked out okay. So I decided to install the Stinger relay back here in this corner, and it's going to be a little bit difficult to get to because it's hard to drill the holes. There's metal underneath of this plastic, so I got to drill through the metal. I'm going to use a couple of sheet metal screws. You can't really see it here, but I've marked where I'm going to put the relay. Let's see. It's going to go right there. And hopefully we can get our sheet metal screws in there. The unit does not come with any screws for that. You're on your own. Here we have the Stinger relay installed in the back. Because it has some steel underneath, I decided I didn't want to drill into that. I just put a bunch of flat washers to raise up the screw, and I have a lock washer between the screw head and this stack of flat washers. So the screw is in maybe about 1/4 inch or so into the plastic, and that was enough. It's pretty secure and will be good enough to wire it up. Well, I tried to use for key on power the harness that I bought from Honda Side by Side Club, and it's a nicely made little device. The harness is supposed to plug in place of the cigarette lighter, which is in the middle, fairly low in the dashboard. After about a half an hour of various new vocabulary words that I made up, and some of which you've probably heard but are not okay to use in this video, I could not get my hand back there well enough to press or even find the lever to press to release this harness. And I went underneath and I'm able to touch it, but I cannot get in there far enough to see it and get enough leverage to pull it out. Now, I don't have a lift, so I can't get the vehicle up in the air. I don't know if that would have helped or not. But in any case, since I already have this other option for tapping in to the accessory circuit, I decided I'm going to give that a shot instead. This is just a little Bussman. It's about $7 on Amazon. If you can get them at Walmart, there's other probably auto parts stores that you can get them. Make sure you get the small, the mini fuse version. Okay, let's try that. Well, now we're going to connect our new method for tapping into the key on power circuit with our little $6.97 adapter here, fuse adapter. First thing we're going to do is pop off the main fuse box cover. You have to press in the little tabs here to get this to pop off. We'll do that. And then you might need some needle nose pliers or something to pull out the 15 amp fuse. It's the 5th one down. I'm going to pull that guy out. I'm going to hang on to it. We're going to place that into our little assembly here. There are 2 spots in our assembly. I don't know if it matters which one is which. It didn't come with any instructions, so I guess we'll find out once we get this thing going. All right, now I'm going to put this guy back in the spot. It's pretty simple. Now, of course, we got to get the cover back on, and there's a little bit of an obstruction, but it does fit if you pop it on there with a little care. All right, so here we go. Make sure I get that out of the way. All right. To finish up our key on power discussion, we started with our key on circuit here at number 5, and it's tapped in. It's spliced in now to a red wire that is coming over here to our stinger. And the stinger also has a negative. The negative is going over to our bus bar, negative bus bar. They're wire tied up nicely. Now, it doesn't matter which side you put on this. You can reverse them either way. It doesn't matter. This is the low current circuit, which will trigger the Stinger relay. The Stinger relay is going to power the fuse box. That's the last remaining connection I have to make for the Stinger. Let's talk about the fuse box. So I have a fuse box that has 10 circuits, which is completely ridiculous because I'm never going to need 10 circuits. It also means the unit is bigger than I would have liked, and so I have fewer mounting options. So it's another stupid thing. Now, if I had it all to do again, I would probably get a 6-circuit model, but still retain the little red light that comes on when you have a blown fuse. So that's a nice feature, but you can get that feature in smaller configurations. I probably would not get one of the square configurations. They have some that are in 4 and 6 circuits, but are square. And square is not your friend when you're trying to find a mounting spot. The 6-circuit model that is a thin, narrow strip is probably the best option, because that would allow us to use a spot like this where it's not sticking out too far. Now, you have to be careful. You only have about 5.5 total inches of height here that you can use. So it's hard to find something that's got 6 circuits and can still fit in this spot. Now, some people mounted their fuse boxes back here. This was my original plan, but when I turned the battery around and oriented the battery wiring towards the back, that spot became really unusable for mounting this fuse box. And I really like the wiring back here. It keeps everything clean. There's a lot less mess going on up here in the electric compartment. So what I'm planning to do is use the air filter cover, if I can get that on here. Some people have done this. I thought it was a little difficult because if you look at the mounting option here, there's a couple of ridges that are sticking up, and this is not a flat surface, so it makes it difficult to, mount this thing. But I do have a solution for that. All right, so now we need to solve the mounting problem for the fuse box using the air filter cover. And the air filter cover behind has a couple of ridges that mean the surface is not flat, so it's not easy to mount the fuse box to it. So what I did was I went out to Lowe's and I bought a little square of a Green Guard project board. It was about $5 at Lowe's, and it's very easy to cut with a utility knife. I cut a approximately 4 1/16 by 2 3/4 inch little slab here and notched out a spot so that it will fit nicely right over that ridge. I can put some of my heavy-duty Velcro down in here to hold this on, and then I'm going to Velcro my fuse box back to that, and I'll have a nice little flat mounting area. Problem solved.
All right, we're going to go ahead and install this switch plate that we got from PBR Products. And we also have to drill out these 5 rivets. And then we're going to use the heat gun to take off the warning label. That's it. There you go. That's one. Now we have all 5 rivets out. We can start with our heat gun to remove the warning label. And I want to heat it up evenly all around. It wants to come off. It's pretty thick too. The heat gun makes a world of a difference. Gotta take your time, just work the putty knife all the way through it while taking your heat gun and moving it around with it.
Here we've scored the switch plate template. You can see that we did a basic outline of the switch locations. We didn't really need to do that, but for purposes of the video, I thought it would be extra helpful. And we measured from the top 3/8 of an inch. We've measured from the sides 1 1/4 inches, and we've measured from the bottom 3/4 of an inch. And that should give us plenty of room to get all the switches in. We're going to cut one big rectangle. We're not going to cut out individual holes for the switches. And that'll give us enough strength and support on the 2 sides and enough on the bottom and the top to keep the switch plate pretty secure, while at the same time not dealing with individual holes for the switches.
This is a DeWalt multi-tool, just your regular oscillating tool that will vibrate and basically cut through anything, including plastic. So we plan on making nice, even cuts to cut out our rectangles so our switch plate will fit. You can also use a rotor zip. We're gonna start somewhere simple, like right here on the sides. Just try to keep it even. Get a piece out. Didn't hit anything. Everything's clean. And we can take our switch plate and hold it up to it and see how well it fits.
Now we're ready to test our switch plate. We're going to connect the dual voltmeter and the dual voltmeter relay. Those are prepared. I'm going to fish the cable harness down in through the hole to the various locations where they need to be hooked up, and we'll do that test, make sure everything's working before we add any other accessories. As we prepare to do our initial testing of the new electrical circuit, we're going to do it with the key accessory turned off, meaning the whole vehicle is turned off right now. We have certain voltages that we want to check to make sure that they are correct before we turn the key accessories on. Let's identify a few components. First of all, the wiring is still a bit unruly. We're going to clean that up and tighten things up once we're certain that everything is working correctly. We have our primary starting battery here. We've got a negative bus bar. We have our Tru Isolator. We've got the main fuse panel with the lid removed. We have our auxiliary battery. We've got our accessory fuse panel. We've got a positive bus bar, and we have our stinger relay. The stinger relay will not be energized fully until we turn the key on accessory. So let's see what kind of voltages we have and what we're expecting. Got our DC voltmeter here. We should be reading 12 volts from the positive and negative battery terminals, of course, the primary. We'll also have 12 volts between the positive and negative of our auxiliary battery. That just double checks that our batteries are up to charge. We're going to have 12 volts, of course, from the positive to the negative bus bar, which we do. We need 12 volts from the positive bus bar to the negative bus bar. We're going to have 12 volts from the auxiliary battery isolator terminal. We're going to have 12 volts from the main battery terminal of the isolator. We're also going to have 12 volts from the stinger relay where the batteries are connected, but we're going to have no voltage from the other side of the stinger relay. You can see it's 0 there to the negative terminal. That's because the stinger relay is not going to be energized until the key accessory is turned on. This post is connected to our accessory fuse box positive terminal, and you can see that it is also no voltage. It's the same connection. So right now, our accessory fuse box is not energized, but we do have 12 volts across the battery terminals where we are expecting them. Now let's turn on the key accessory. And we expect to hear the stinger relay energize. You might hear it click. I don't know if you'll be able to hear it. Here it goes. Okay, just clicked. Now, once that relay has been energized, we should now have 12 volts at our fuse panel. And indeed we do. So the stinger relay here has been energized, and we have 12 volts at our fuse panel. We should also see the dual voltmeter has been energized. Let's go take a look at that. So now we have our dual voltmeter is working. You'll see that the primary battery is up to about 14 volts. The auxiliary battery is up to about 14 volts. When we turn the key off, the dual voltmeter goes out. All right, so you'll notice when we turn the key off, there's a blue light on the isolator that will remain on for a while. And that's because the isolator still allows for the auxiliary battery to remain in the system as long as the voltage is up over, I don't know, I think it's about 13 volts or something like that. So if you want to test and make sure that it's going to shut off properly, you just need to get the voltage down on the primary battery. One way to do that is to turn the accessory on and turn the lights on, let them stay on for a moment, and you'll see the voltage has come down now to about 12 volts. So if I turn the accessory off now, you'll see that the blue light is now out. Here's the switch plate completed for now. I don't have my lights hooked up yet. We're not going to do that in this video. And I don't have it screwed in yet. I am going to get some black screws to finish the mounting. The wiring is fairly neat, and each pair is wire tied together for easy identification. It's easy to pull out. I've got plenty of slack for servicing. Let's see now. So when we go to auxiliary power on, which is just the key, our dual voltmeter will come on, and you can see our USB charger is ready to go. I don't believe there's a light on this guy. No, there's no light, but they have been tested and they do work. So we are finished. Well, we're ready for our final tour, and let's see what we've got. We have some red electrical tape on top of the positive terminals wherever they are. I might be a little overcautious, but I like to cover up the positive terminals, and you'll see that I've done that here on the auxiliary battery. I've done it around the positive bus bar. The tape is very easy to pull back if I need to add more accessories. The Stinger positive terminals have red tape. I've got red tape on the fuse box, positive lead right here. For fuses, I'm starting out with a 5 amp fuse. This is for our voltmeter. I have a 5 amp fuse for the USB charger that's also in the switch plate. And for the cigarette lighter adapter that's in the switch plate, I have a 15 amp fuse. Now the reason for that is because I have a 150 watt inverter that I've tested out, works great. And 150 watts divided by 12 volts is 12.5 amps. So I picked 15 amps as a good size for that. You can see I've tied up the positive leads coming off here. Obviously, when I add more things, I'm going to add a light bar and some backup lights. You can put those accessories in the main fuse and have them part of the regular light system. I'm not going to do that. I want them separate on the auxiliary side. You can see I have the negative cables tied together, and then they are grouped together and tied up and run very nicely and cleanly back through the back. I didn't really do much cleanup back here. I have some slack that I can use when I need to do any kind of maintenance when we pull the switch plate out, and there's a lot of space back there, so I didn't try to make that too tight and perfect. You can see here we've got our negative bus bar. I've done a little bit of cleanup with some zip ties, and these are all tied in nicely. If you remember, one of the first things we did was we tied in a trickle charger and ran that through some 3/8 inch flex tube, which goes down through to the front grille. And if I can even remember what I did with that, it's down here. The little charging, how you doing, is right down there. And let's see what else. The negative side I did not cover with tape. Generally, you'll see in engine compartments that the negative is not protected, but the positive usually is. I believe that is it. So let's button her up and take this thing for a ride.